Okay, guys, we're going to do this last little bit of the math. You can just hold on with me. So if you'll look at question 31, this is one of your homework packets. We've got Lanoxin, 125 micrograms is ordered every morning. The vial contains 0.5 milligrams per 2 meals. How much medication in milliliters will the patient receive in a single dose? So remember, the big thing here, we've got to do apples to apples. So if you look, the order is 125 micrograms. The available is 0.5 milligrams. So you got to convert, and remember to convert micrograms to milligrams. We divide by 1,000. So when you divide by 1,000, you get 0.125 milligrams. Then you go straight into your regular DHQ, 1.125 milligrams over what is available. That's 0.5 milligrams times your quantity, which is 2. That ends up giving us 0.5 milliliters per dose. Okay. Next one, 32. Here is another grain. Atropine is one of the others. So it is 60 times the 150. And I'm sorry, I missed this whole problem. 60 times 1 over 150. And that's going to give us, it ends up being like 0.39, somewhere around in there. So it rounds to 0.4. If 0.4 milligrams is our available, then we can simply divide by our desired by our available, which are the same. So once we do that, we're going to do our quantity is times 1. So we get 1 milliliter is our dose, because 0.4 divided by 0.4 gives us 1, so 0.1 milliliter. And then this one, we've got our newer math. This is the micrograms per kilogram per minute formula. This is the whole formula. It's micrograms times kilograms times 60 over 1,000. You take the results of that and put it over available milligrams and multiply times X over available milliliters. So we just plug in 4 micrograms. We already have kilograms, so we plug that in here. And we know 60 is a plug-in, then divided by 1,000. So 18,000 divided by 10. Gives us 18,000 divided by 1,000 gives us 18. So then we take 18 over the available milligrams times X over the available milliliters. So that gives us 100X equals 45,000. So you have to isolate X by dividing both sides by 100. That's going to give us 45, I believe. Let me check my math. That's why. So 4,500 divided by both sides divided by 100 gives us 45. So then that is our answer. So the next one, same issue, same type of problem. We've got our formula, which is micrograms times kilograms times 60 over 1,000. Results over available milligrams times X over available milliliters. So we plug in again. We need to convert the 230 pounds to kilograms, which is 1 over 4.5 kilograms. Our micrograms is 3. Kilograms is 1 over 4.5. Still times 60. That's over 1,000. We do the math here. The result is 18,810. We're going to divide by 1,000. That gives us 18.81. We put the 18.81, our results over available milligrams. and then times X over available milliliters. The way I remember it, G in the alphabet, A, B, C, D, F, G comes before L. So milligrams is first, milliliters is second. We just happen to have the same amount here. So you cross multiply, 500 times the X comes 500X, and 18.81 times 500, 9,405. We do the math, divide both sides by 500 to isolate X. We get 18.81 or 19 milliliters. So that is it, guys. I hope that helps. I'm going to stop the video now. If you have any questions,